Welcome to JuiceIT Digital 2021. My name is TK Kianini. I'm the Chief Technology Officer for the Security Business Group at Cisco. We talked today about having a telemetry architecture, and I really want to bring it home and show you something real. I want to show you a demo of what it is to have a telemetry architecture. We're going to actually do a demo of the Cisco Telemetry Broker. So with that, let's get started. Here we go. This is the Cisco Telemetry Broker in action. So I'll go and set up the demo so we have an introduction and you can understand how things are set up in the environment in the context of the items that are sending telemetry, how it gets to the Cisco Telemetry Broker, and then how the Cisco Telemetry Broker distributes that telemetry out to the destinations. In the demo, you'll see basically how the interface is laid out, how you configure things. We'll go through some use cases so that it makes sense to you. And then we'll end with a conclusion. Let's start again with an overview of the problems the modern day architectures are facing given the explosion of analytical platforms. At the bottom, you can see you have a bunch of sources of telemetry. They're sending to a particular destination at the top. So here you have network management wanting a copy of some of the telemetry. You may have a security management setup wanting a copy of the telemetry. You may have a SIM setup that also wants a copy of the telemetry. You can get the pattern here. Everybody wants a copy of the telemetry, and without an architecture here, you do run into problems. The one that is probably the most popular are all the SaaS services that can offer you some great analytical outcomes, but you just got to get the telemetry over there for that outcome to happen. So this is what the diagram looks like after. You have a distributed architecture that is in the middle. That is the Cisco Telemetry Broker. The user story for the sources is, as a producer of telemetry, I just want to send to a single target, regardless of how many consumers there are. So once they reach a highly available IP, be it V4 or V6 IP, they're really done. And as a consumer of telemetry, I just want to treat all my telemetry as code. I want to specify, that I want a particular protocol from these networks. And I don't really need to go and touch the configurations of all those servers and switches and routers, applications, firewalls. So that gets a little crazy. And this is the problem we're trying to solve. I want to talk about how you go about deploying the Cisco Telemetry Broker. Cisco Telemetry Broker runs on VMware. So it really is sort of a bring your own hypervisor. There are two pieces of software. One is the broker node itself. These are the broker nodes that are distributed all over the network, wherever you need them. They can do 10 gigs per second, or they can do 1 gig per second. And depending on that, it's either 2 cores or 5 cores. It's very, very lightweight and very high performing. And then there's the management node, which manages all of the brokers. And that requires a guest instance of a machine that has 4 cores and 8 gigs of RAM. So again, very lightweight and very, very high performing. Let's take a look at our demo environment because we want to have this mental model as I go through the demo. Again, on the bottom, we have our sources. These are things that are emitting telemetry. And on the top, we have our destinations. So I have an instance of Cisco StealthWatch running with a flow collector. That'll be a very high performing collector at the top. You could have, Splunk at the top. You could have a network management system. At the bottom, I have a bunch of infrastructure, routers, switches, firewalls. They're all sending NetFlow, syslog, some form of telemetry up. And in the demo, I'm also going to show you how we take AWS VPC flow logs and convert that to IPFix to send to StealthWatch in a very native and understandable format. So again, there you have a modern form of telemetry going to a more legacy form of telemetry. In the middle, we have the telemetry broker. So you have two broker nodes that are paired up, and we have two pairs, so two high availability pairs. And then I have an instance of the node that is just taking care of the AWS VPC flow logs to IPFix. And then of course on the right side there, that blue icon, that's the management station. Primarily we'll be interfacing through a web browser to that management station. And I'll take you through all of it so we can understand the environment that this demo lives in. The demo flow is very straightforward. We'll go through an overview of the UI. We'll look at the manager, and we'll go through administration, setting up the TLS certs, software updates, adding users, removing users, all the admin functions. And then we'll take a look at destinations. So we'll start at the destinations. So this is, again, in my environment where StealthWatch is living. We're going to actually show you how to check on that destination, make sure it's healthy. We'll add a destination, we'll edit the destination, and then we'll go and look at sources, and we'll look at the distribution nodes and how we go about connecting the source of telemetry through the distribution node to the destination. So very straightforward. We'll look at features like the high availability clustering and also the translation we do with AWS VPC flow logs. So once you get your software running in VMware, you can point your browser at the management IP and you log in with your credentials. So this is the first screen you see. Again, a very, very simple layout. This is the Cisco Telemetry Broker, and what you're looking at right now are the destinations. So these are ultimately the analytical platforms that are receiving telemetry. You can see here I have Cisco StealthWatch, the flow collector. You can see the data that it's being received. This is an important part here where it says reachable. The Cisco Telemetry Broker has a way in which it can check if the destinations are reachable, and we'll get into why that's important a little later in the demo. But I want to take you across the UI and just kind of give you an overview. So here you have your sources. These are the things that are emitting telemetry. We can see here that there seems to be a lot of infrastructure sending NetFlow on port 2055. And these are the broker nodes. So these are the nodes that are receiving telemetry and then brokering that to the destinations. And then you have the manager node itself. Here you can see the health of the manager node, its memory, its disk, its load average, all the things you need to be a good admin for this particular management system. And then we have an integrations tab here where we will show the configuration for integrations. In this case, the integration is AWS VPC flow logs. Let's come over here and look at some of the application settings for the management node. We have HTTPS proxy set up because we have to get out of our lab and out to the internet to get to the VPC flow logs in AWS. We have a way to manage the hygiene of the system, the software updates. You can see here we have smart licensing, which again just makes it easier for you to evaluate and then purchase what you need when you need it. So here we're in evaluation mode, which is usually where you start out download, and then you can actually register and purchase whatever you need. Here we have the user management. Very straightforward. I just have a single user, single Titan user here. And then lastly, we know that we can secure these systems with X.509 certificates. And so you can put in your certificate here for your corporation. And this both is your browser connection to the management station, and also the broker nodes use certificates to ensure that it's connecting safely to a management station that has integrity and is the one you want, the authentication there. So again, here's where you upload your TLS certs, and pretty straightforward, simple interface. I just wanted to give you an overview. Again, only 5 tabs here, very simple setup. So let's get back to the destinations. Within the destinations, I just want to show you how easy it is to set things up. Here we're looking at something that's already been set up, but let's say you get a phone call on a Monday and somebody says, hey, we want to try out this new service. We just need to send syslog over to this new destination because it does these cool things. Well, normally you would have to go out and schedule change control. You'd have to go out and maybe visit 40, 50, maybe several hundred servers that were sending syslog. I'll show you here. We can do it in just a few clicks. So you say add destination. I'll just call it the syslog server. We give it an IP address. Let's call it 10.6.14.4. Destination port 514. We can test the reachability here, and I'll explain that in a second. So there we have it. We added the destination. It's here. You're basically done. You just go down here and say add a rule. We want to receive 514 from all networks, and you are done. That is it. That's how simple it is when you have a telemetry architecture to add another analytical platform that's going to be important to your business. What is that? 5 or 6 clicks and you're done. So again, the reachability is really interesting here. The reason why that's important, okay, is because when you're getting all the telemetry from your enterprise, which may be a very significant amount of data. If, for instance, one of these destinations were to go offline, okay, let's say it goes offline for a couple of hours. If your telemetry architecture isn't smart, the broker nodes will continue to send the telemetry to that destination that isn't there. Well, what will happen in TCP/IP is you will get a ICMP host unreachable, port unreachable storm. And this is a bad thing. It just shouldn't happen. Your systems should be smarter than that. So here, what's happening is the broker nodes are testing to see whether that syslog server is there. And if it isn't there, it actually won't send the telemetry there. We might be talking about gigabytes per second of telemetry that is not going to be sent because it's not reachable. So when it comes back online, that'll pick up. And again, it's a safety issue really. When you're operating at scale, you have to care about these things. So again, that there is in fact how you add a destination. And if you want to remove a destination, it's as easy as yes, remove. So there you have it. That's destinations. Now let's take a look at the sources. So when we look at infrastructure, like servers, routers, and switches, you're usually talking about syslog, you're talking about SNMP traps, you're talking about NetFlow, IPFix. We have a tab specifically for that. And again, we can see what the status of that sender is, that source. We can see how many destinations have actually subscribed to that source. Again, the rate in which that telemetry is coming in and things dealing with performance. Now, on the other side, we also have VPC flow logs coming in, and you'll get a better understanding of this when we go over to the broker node, because on the broker node, we can see things coming to the broker node and things leaving the broker node. But I just wanted to show you in the interface, how you go about looking at what your infrastructure is sending your telemetry architecture. Let's take a look at the broker nodes for a little bit. So with the broker nodes, again, you can have as many as 2, you can have as many as 200. The idea here is you want to put broker nodes where they're reachable by your telemetry senders, your telemetry sources. So in this case, I may have, in my diagram I showed you, I have a pair that are acting as a high availability pair. We're calling it cluster A and cluster B here. So on the top, I have the active cluster A that's at 10.0.81.216, and I have its standby buddy here at 10.0.81.214. And you can see cluster B here, and then of course, like we showed in the diagram, this 10.0.81.212 is actually the node that is facilitating the VPC flow logs to IPFix translation. So here down on the bottom, you have a graphic representation of the clusters. You can have 2 or more. There could be 3, 4, 5 in a cluster. In this case, I have 2. These could be one in your West Coast data center, one in your East Coast data center. To add a cluster, you basically, put in the cluster name. You go ahead and subscribe the broker nodes to that cluster, and you can give it a V4 or a V6 address. It's really, really simple. And mind you, like these addresses here, this is all you need to do for your infrastructure to point at. So you may have an address on the West Coast and an address on the East Coast, and it's the same address in the case of Anycast for UDP. It might be different addressing, but again, the idea is that all of your infrastructure is going to point at some well-known V4 or V6 addresses that are incredibly high availability. And so that's how you do that. Again, very, very straightforward. You don't really need to even open the documentation to understand the interface. Again, we looked at the management node. Not much to see here, really. You have a host name, its IP. Again, that's what my browser is pointing at. You have the stats from the actual machine. Let's actually look at what it takes to configure the VPC flow logs. So when you configure the translation of VPC flow logs to IPFix, the first thing we'll actually look at is the actual broker node that's doing that translation. So we see that it's active. We can see that it has a nice little cadence on its traffic here. Let's go and look at the integration itself. So we go here and we say add AWS credentials, and here we give it the key ID, the access key. This is the authentication that the broker node is using to reach out to the S3 bucket to grab those VPC flow logs and bring it back. And so by doing that, that gets assigned to this particular broker, and we can go back here and see that this broker node is doing that translation and is sending it to the collector. In this case, it's StealthWatch, this destination here. So this destination is receiving not only the infrastructure telemetry, in this case, it's IPFix on UDP 2055. There's 6 sources coming to it. it's also receiving VPC flow logs in the form of IPFix that's going to this particular Stealth Watch instance that is taking in, again, all of the telemetry that's coming from the telemetry broker. So with that, I don't think there's anything else to demo. We'll just go ahead and log out. Thank you very much for a great demo. So I'd like to conclude by showing an overview of a more protocol-centric view where on the left you have the sources of telemetry, and in this case the protocols themselves coming through a telemetry architecture, which is the Cisco Telemetry Broker distributed nodes. They broker, they transform, they filter, and then on the right you have some consumer, some destination that's delivering value to your business. So again, you might have Cisco Stealth Watch, you might have Cisco DNA Center, it might be Splunk, it might be some SaaS service, but again, we're flowing left to right. And a telemetry architecture ultimately is going to democratize your telemetry data. No one destination has exclusivity anymore. So this, again, allows your business to monetize that telemetry for the analytical outcome that's going to be important for you as you leverage more machines, as you go from human scale to machine scale. Here again, we have the product page, some blog posts that take you through the broker, the telemetry broker. It also talks about, again, that telemetry architecture. I want to thank everyone for letting me share this view on telemetry architecture and the Cisco Telemetry Broker. You can visit Cisco at the JuiceIT Digital Showcase anytime today or tomorrow. If you're interested to unpack your infrastructure telemetry or understand how we simplify security telemetry with Cisco SecureX, please get in contact with Cisco or Data3 to discuss further. Thank you so much. Goodbye.